This video is about looking for patterns or correlation in scatter plots. Let's revisit our ice cream sales example to explore correlation. In this scatter plot you can see that all the data does not lie on a straight line. You can also see though that the data is reasonably close together, and when we put the line of best fit on, it seems to generally lie close to a straight line. What we're doing here is looking for a relationship between the two variables. Here we are dealing with bivariate data, which means that we have two variables, in this instance temperature and ice cream sales. And we want to see if there may be some kind of correlation or relationship between these two variables. Looking at the plot, we might be tempted to say that there is indeed a relationship between the two. In fact, it appears to be quite a strong positive linear correlation. That is, as the temperature increases, so does the sale of ice creams. There are four main ways to describe data: perfect, strong, weak, and no correlation. The only other thing to mention is whether the correlation is negative or positive. Here in A and B, we can see that the data is perfectly linear. That means that all of the points lie on the straight line. In C, we can see that the data has a negative correlation. It goes down the page from left to right, and that the data is close together. So we would say that this is a strong negative correlation. As X increases, Y decreases. In D, we can see that the data has a positive correlation. That is, it goes up the page from left to right, and that the data is also close together. So we would say that this is a strong positive correlation. As X increases, Y also increases. In this picture, we can see that the difference between strong and weak correlation just refers to how tightly the data points are grouped near the line. In A, it's a negative correlation, but it is strong, whereas in C, it is also negative, however the points are more spread out. So we would say that it was a weak correlation. In B, it's a positive correlation, and it is strong. D is also a positive correlation. However, the points are more spread out, so we would say that it was a weak correlation. And finally, we can see that some data has no correlation. It is neither strong or weak, positive or negative. So let's go back to the ice cream. We can see here that the data has a strong positive correlation. Don't be tempted though to say that this means that there is definitely a correlation between the two. If the temperature is high, then ice cream sales will also be high. In order to see if this is actually the case, you'd need to look at other contributing factors. For instance, where were these sales actually taking place, and how many people were actually there? If this was at the beach, and we're considering the difference between winter and summer, then most likely the ice cream sales increase purely because the number of people at the beach during summer, the warmer temperatures, also increases, not because warmer temperatures means more ice cream will sell. The point is, don't just look at one graph and decide a true relationship actually exists. Make sure you truly think about the data and ensure that any statements you make regarding conclusions are in fact true, or at least you've given the alternatives. Let's take the same graph and think of it as being feet size versus intelligent. It looks like as feet size increases, then so does intelligence. The bigger your feet, the more intelligent you are. The truth is probably not quite so easy. For example, in this instance, small size feet probably means children, and children probably don't score as well on an intelligence test written for adults. So whilst a graph could look like there's a positive correlation, it's most likely in that case not a true correlation between feet size and intelligence. All I'm saying is think about what the data is that you're looking at and compare it to some other things to see if it actually is logical for the two to be strongly correlated.